Good morning and welcome to this new SIGAL video. Today we're going to talk about AVO analysis and data reconnaissance using Blueback Seismic Reservoir Characterization and Blueback Investigator. So first of all, thank you for signing up. This is so the last video of this series is on Wednesday, so please sign up. Keegan is going to talk about practical Python. We're looking at running another series, so please let us know what you want to see. If you want to find out more about any tools, please contact your SIGAL account manager or emails at sales@sigal.com. So the format, so each session will last between 20 and 30 minutes. Each session will be recorded and you will get a copy of the recording via email 24 hours after the webinar ends. The recording will also be available on our SIGAL YouTube channel. If there is time for question, can you please submit your question via the chat tab in the GoToWebinar console? So today's summary. The situation is we have anchor stacks for our project. We have near, mid, and far. Intercept and gradient were created in a previous video. So what we want to do now is to see if we have a potential reservoir and we want to create and analyze AVO on our volume. So the workflow will follow two parts. The first one, we're going to create the AVO volume using AVO classification tool. On the second part, we will do the AVO analysis using Blueback Investigator. But let's jump into Petrel. So this is our data set. We have on the left-hand side our intercept volume, and on the right-hand side our gradient volume. I've just cropped my volume to have something that can run very quickly, but our volume is roughly 9.4 kilometer, about and 8.6 kilometer, and about 1 second seek in time. So the first step is to create an AVO volume. To do that, I'm going to use Blueback Seismic Reservoir Characterization. So when you open Seismic Reservoir Characterization, you have first of all the proposed workflow. So seismic intercept and gradient here was used on a previous video. So we already have our intercept and gradient that I'm showing on the background. So today I'm going to use AVO classification tool. So this is the tool over there. So for all our tools, you have the tool on one tab and the help on the second tab over there. So the help here help with the different classifications, so the different class, and also the references that we used for the creation of this tool. So this tool works with different type of dataset, Seismic 3D, numeric, wells, model, Seismic 2D. Today I'm going to use Seismic 3D, so I keep this one. And the tool works also in depth or time. So I can select my intercept and gradient, so either using the drop-down menu or by using the blue arrows. So here I'm selecting my intercept and my gradient, and I can click now refresh. So now when I click refresh, the tool will just plot the intercept versus gradient for all the points. So by default, the tool decimates my data, and here I have a maximum number of points of 200,000. If you want more, you can just type. It's just to have something that is meaningful, and it's something that is not running for a long time. So you can see here that I have my points in white and the different type of classes. So the tool allows you first to decimate. You can decimate using a top and a base if you wish to, and also a boundary. You can also select inline crossline and a step if you want to decimate. The second step of the tool is, if you wish to, you can mute. So you have two types of muting shape, either an ellipse or a line. So I'm going just here to use an ellipse. For the parameterization of the ellipse, we have two parameters, the A and B of the ellipse. So here I can just now type the parameter and you can see my ellipse on the right-hand side. You can see that I have two ellipses. I have an inner one, which is grayed out in the middle, and everything that is grayed out will be muted. I have also an outer ellipse, and it's my strength ellipse. So this means that I will be able to have a measurement of the strength of my AVO effect. So this is my ellipse, but I can now rotate it, either by using the slider or by typing the value. So here I can do it like that. So if I zoom a little bit, for the strength of my ellipse, it means that if a point lay on the inner ellipse, the strength will be 0. If a point lay on the outer ellipse, on the strength ellipse, the strength will be 1. If it's lay between the two, in the middle, it will be 0.5. It doesn't mean that the point outside will have no strength. It's just that the tool will create outer ellipse like this here, as displayed in the help. So this is the ellipse, but you can also just use a line if you wish to, and you can also mute above the trend if you want. So for this example, I'm just going to use the ellipse. Then you have some AVO class definition if you wish to. First, you can change the angle for the class 2P definition. By default is at 30 degrees, but you can change that. And you can also change the color of your classes if you want. You can also define the active classes. If you deselect, let's say, class 1 and 2, in the output volume, it will be black. So I can create, just for my output, I just select a suffix, and I'm going to create also an AVO volume, but also a strength seismic cube and a strength seismic cube color by class. So now when I click apply, the tool creates virtual volumes. So I'm just putting this on the side to have a look at my output. So I'm just closing my windows and opening a new one. So I have 3 outputs, my AVO class demo here. So everything that is black was because the points of the sample were inside the inner ellipse. And now you can see that I have some color. So I have some weird edge effect around my color, and this is due to the color template that we are using. So if I open the settings of my volume and here, and I open the color table, so Petrel doesn't use a discrete color template for seismic, so it's a fake discrete template. So to display fake discrete template, you have to remember to put the interpolation method on none, otherwise Petrel smooths the data. And here we have something more meaningful. So here, let me put the background on white. So here we have now, for all the volumes, the AVO class. The second volume created is the strength. So it's just how strong is our AVO effect. And then the last volume is our AVO class strength. So you can see again, we have this weird edge effect. So you open the settings of the tool and you change the interpolation method. So now this volume, which is a AVO class strength, the color is by shades of color. So the stronger the shade of the color is, the stronger the strength of my AVO is. But the tool makes use of the fact that we create virtual volumes. So if I go back to my tool, if I select another parameter, so for example, I can either change the muting size, or I can mute above trend. So now everything that is above my trend will be muted. If I click reuse now, just put it on the side and click apply, the tool updates on the fly. So I can easily test. I can also easily change the some parameter in my ellipse and test it very quickly. We also have an option to use multi-ellipse if you have analyzed that you need multiple size or multiple orientation of your ellipse. You can select multiple ellipse for your volume. For this dataset, I'm just going to use one volume. So this is our AVO. So I've created earlier my AVO class, which is here. I've realized it. Again, you can see that my color is weird, so I'm just changing. So this is my AVO. So here you can either analyze your AVO volume just using the volume, but we're going to use Blueback Investigator to go into more depth in our analysis. So Investigator is our multi-domain data analyzer. First, when you want to use an Investigator, you need to create a new Blueback investigation. So just to do that, you have just to go to Object, New Object, and New Blueback Investigation. So the tool works with different type of data sets, so check shots, model, and so on. So here I'm going to work with Seismic 3D. For seismic volume, you need to select first your geometry, so the survey of your volume. So I can select the survey near and then add dimensions. So here I'm just going to use my intercept, gradient, AVO class, and I'm also going to bring my class strengths. Then I just have to click apply. I can give it a name and click apply. And this new object is now saved in my Petrel project. So I'll put this on the side. So now I can visualize my data through different Blueback windows. So we have Blueback histogram window, Blueback crossplot window, matrix window, parallel coordinates window, and Blueback Investigator 3D window. So first, I'm just going to open a Blueback matrix window. The Blueback matrix window will plot all continuous dimensions against each other, like so. So here we have on the row, so intercept, gradient, AVO class, and VO class trends, and again, intercept gradient. So here by default, it's colored by dataset, but I can color by my intercept, for example, or gradient, or AVO class. So here I can start to analyze the different number of points per class and so on. The only negative side, it's because my AVO class is a continuous volume, I can't select only one class. So we have a tool that allows us to create a discrete dataset for a seismic volume. So to do that, we go into Marina and into Blueback Investigator. When you open the tool, we have a tool called Discrete Template Generator. So this tool will create, as its name says, a discrete template coming from different of input. So either a table, a template, an existing template, or a seismic. So here I'm going to bring my AVO class volume. And now I have this. I can just read the data. And it had read that I have 9 code 0 from 8 with the associated color. If I click apply, the tool has now created a new color template and a new discrete template. So this is my color template and now my discrete template. With the associated code. So now I can use this discrete template in my investigation. So to do that, I'm just opening the settings of my investigation and I add a discrete dimension. I select my dimension and I just assign to this dimension my discrete template. Now I can assign my volume to this discrete template. And when I click apply, this will update my matrix plot on the background. And now in the discrete data control, I have all the codes available. So now I can deselect the code 0, so the data that was muted earlier, or select code 1 and so on. So now I can also, if I wish to, toggle my statistics and have for my each class, let me change that a little bit, the number of points per classes, min, maximum, and so on for all the dimensions that are displayed on my matrix window. But so this is quite interesting, but what it's nice and what I want to do is to analyze some points and understand where they are in my volume. So to do that, I'm just going to open a crossplot window, select my plot, and I will also tile a 3D window. I will add my intercept just to add some context. And I want to tile both of them. If I want to display my investigation in my 3D window, I just need to do one more step, which is in the settings of the video to add spatial dimensions. So here I'm just going to add X, Y, and time. I click apply. And now if I select the 3D window, I can select my investigation, my Blueback investigation, and all my data set is displayed. So you can see that I have some large area between each sample. It's just because here the step is 22. I can refine it, but just for the purpose of this video, I will keep the step as 22 so it's running smoothly. So now I can also control what I'm seeing in my 3D window. The control of the 3D window is in the settings of the investigation in Petrel Windows style. So here I have the very similar control tab. So I can control the color of the data. I can color it by intercept or by my AVO color. So if I put it in white. So here it's not really interesting. It's a lot of black, but I can deselect the codes I'm not interested in. So here I've removed all the black points, all the points that were muted. I can select only the code 2, for example, or just code 2 and code 3. What I can also do is go into my crossplot window, color it by my AVO, and I can create a filter. So let's say a polygon filter. This polygon now is saved in my investigation. So if I go in the settings of my investigation, highlight my 3D window, this selection is also available. So if I go back, display everything here, I can select my filter, and only the points that are in my filter are now displayed in my 3D window. So if I move my filter, everything is updated on my 3D window as well. So I can multiply the filter. So I can use this filter, but select only the code, the other code to remove all the code 0 and so on. Another way of filtering the data is to use a spatial selection. So a spatial selection is an object that is defined in space. So here, if I open the settings, I've created earlier a spatial selection. And for this spatial selection, I've set the vertical limits around the top of my reservoir, which is this surface over there. So I know my reservoir is here with an offset of 400 milliseconds above and below. So 200 milliseconds above and below. I can use this spatial selection to as a region of interest here. So if I use this, now if I click apply, only the points that are within my spatial selection are displayed in my crossplot, but also in my 3D window. So now at the moment in my 3D window, I'm displaying the points that are only in this spatial selection and only within this filter. So you can see that I can refine my investigation and my AVO analysis quite a lot thanks to Blueback Investigator. So this is the end of my analysis. So thank you very much for watching. We love your feedback. So as I said, this week is the end of this series. Let us know what you want to see if you want more. If you have any question, please do not hesitate to send an email to support.geo@cdgat.com. We also have two videos this week, very interesting videos. So we have the last of this series on Wednesday about practical Python, lithophase classification from seismic attributes. And we also have a global webinar tomorrow, so Tuesday, 21st of April, and the subject will be depth inversion. So, and the title is "You might not be on time, but you definitely need to be in depth." And it will run at in the morning and in the afternoon. So, do you have any question? And again, thank you very much for watching. So we have a question. So is it possible to use near and far angle stacks instead of intercept and gradient to classify the AVO? Let me check. So here, if I want to use my near instead of my intercept, yes, you can. As long as it's a seismic volume, if you have selected seismic 3D, yes, you can. Do you normalize, decimate the seismic cube? No, usually I do not decimate. I think it depends of how big is your volume, how large is your area of interest. You can decimate here using either a top and a base, which can be nice if you want to refine your analysis on a reservoir or on a thickness around the reservoir. Or you can also use boundary or inline crossline and with steps. If I have a very large volume, I will try to increase a little bit of the step just to have some a little bit more points and something more manageable. So there is no other question. It was a short video today. Again, thank you very much for watching. And if you have questions after, do not hesitate to ask the support. Thank you. Bye-bye.